It's time! Welcome to watch my video. Have a good day to my lecturer, ZANARIAH, and all my friends. So today, I'm going to show you all the technologies in teaching and learning mathematics, which consist of online and offline software. Furthermore, we are going to explore this application through computational thinking and its various uses in mathematics education. Start off with online software. When we talk about online, it must have a technology device that connects with internet. So for the online software, I choose to use Scratch. So Scratch is a block-based programming platform. It is simple, visual, and perfect for students as an education tool. But more than that, it brings math concept to life through interactive projects. Thus, I plan to use Scratch to code an interactive game. Math and coding might seem different, but actually they go hand in hand. In this video, we will see how using Scratch helps students learn math through computational thinking. So before we designing the game, I used to refer back Document Standard Curriculum and Pentaxera, which is DSKP. So as a demonstrate, I used to choose Year 1 Topic 2.2, which is add within 100. So I need to base on this learning standard to design the game, so to make sure that the student claim the learning objectives. As a result, I have designed a game with Scratch which named SOKOSUM. So actually it is derived from a game called Sokoban. So what is Sokoban? Sokoban actually is a puzzle video game in which the player pushes the boxes around and trying to get them to storage locations. So now, I'm going to show you all the coding process of this game. First of all, we have to create the sprite, which known as the character. So as far as I'm concerned, Sokoban consists of 3 elements, which are player, box, and goal. So first, for the player, I have designed 4 different types of facing, so it can change due to the control. So for the box, just use the square tools to draw it and use the line to design, so it looks as like a box. So for the goal, I use square shape to represent it. In this game, I have added a player place to act as a tunnel. As you can see, the player place have 3 different colors, which are red, green, and yellow. So those colors represent different commands. Now, to make sure the player move orderly, I have drawn an 8x6 grid so that I can measure it and coordinate accurately for every sprite when coding. As we can see, it have the x-axis and y-axis as a reference in the Scratch. But to me, I used to plot the grid from the left to right as 1 to 8, while from the up to down is 1 to 6. After designing these sprites, let's start coding. Although it looks complicated, but actually the coding are quite simple, and it rarely takes a long time to code for the first one. But just we try and error to do it. Start with the player movement. So firstly, just set the coordinate for X grid and Y grid, so it can randomly drop on any place when we start the game. Then let it move with WASD, up, down, left, right, so that we can control the player to anywhere, to any grid, based on the grid that we designed just now. And also, to prevent any bugging, I have set when the player touch the left edge, it will continue move to the right edge. And also the same, when the player touch the up edge, it will continue to the down edge, so that the player can move smoothly in the grid. After that, code the restart key to let the player to start over, just to prevent any lagging situation, and so that the player able to start over. For the box, it's also the same. The first, set the coordinate so it can move randomly, drop at any place when start. Just the bottom part we need to adjust. So at the bottom part, I have added a command push. When the player touching the box will move, based on the direction of the player. In this part, we keep try and error so that it actually move based on our player. Next, coding the goal. The first step still remain the same, coding for randomly coordinate so that it can drop in any place when start. Then, set the command when the box touching it. Okay, now add on a sound effect to make it interesting. As we can see, the goal acts as the point so that the box need to go to it. Now, come to the most important split, which is player place, we know as the tunnel. So the first step, randomly coordinate, so it can drop on any grid when we start. Okay, the first step actually is all the same. So we just copy and paste for all the split. Okay, then give the command to let it change from the red color to yellow color when the box is touching the goal. Then, when the player touching this yellow tunnel, the question will be up here. So this is the place where we integrate the math education. Okay, now set the question in the range of 1 to 100 according to the DSKP. So don't forget the DSKP. When the answer correct, the player will continue start with a new level. If not, the player will restart the certain level. So far, the game is actually done. Just to add on some element to make it more interactive. And after the design, now it's time to demonstrate how to play. And now, when we open the page, actually it will look like this, okay? We got the title here, and we got the game at here, and we also got the instruction about how to play, okay? The key to move and the key to restart, okay? And also the way how to win the level, like control the player or push the box and then answer the question. Okay, we already dropped down here so the player can look clearly. So at the below we got the notes and the credits. So we got the introduction for the Sokoban, okay, and also the point, the input of the technology in math education, and also we got the computational thinking. So when the teacher or the student, they can read, okay, what is this game about, so that they can get the input of this game. Before we play, make sure it is on the full screen mode. Okay, now just click on this button and we will start. Oh, so actually it's got the background music here. And now we will control the player with WASD. Okay, so move it. So we gotta push this box to the green square. Okay. So when we push on it, the circle will turn to yellow color. And now we need to control our player to the yellow circle. Okay. And now the question will be up here. Now we try to do this addition question. So 59 plus 16 is equal to 75. And now we enter the answer. It will turn into green circle. And you get that? Okay, now we try again. So control the player and push it into the goal place. I got a sound effect. Okay, now continue to answer the question. Okay, 37 plus 5 is equal to 80. No, it's 42. We got a sound effect. Okay. So now we already got level 3. Okay. So we continue play. We'll play very fast. Okay, just to answer the question. 97 plus 11 is 8. So look at the record level. Actually, it's already record the highest level of us. Okay. Okay. Now we demonstrate the wrong answer. Okay, just we demonstrate the wrong answer. So we will remain the same on the level 4. Okay, we will never run to the next level. Okay, just to continue to play to up the level. So this is the point of this game. And also don't forget to play the addition question. Okay, this is the last question we demonstrate. 1, 5, 8. So this is the SOKOSUM. Back to the video. So what computational thinking have integrated in this SOKOSUM? So firstly, we will go with decomposition, breaking down the problem. Firstly, displaying a question. So the question is to play this game and then score it to level up. So this is the question what we want. Okay, so we just let the student to know that, oh, they should play, or after that answer the question. So this is the first problem. And then getting input. So when we answering the question, we will get the input, okay, the additional. We get strong, okay, enhance our calculation. And then checking the answer, whether it's right or wrong. If we correct, we will level up. If you wrong, remain at the same level. Next, we'll be going to pattern recognition. For example, when we're looking on the player sprint, we have to control the player to push the ball. While we see the box, we have to push it to the green square. So in this stage, when we're looking at the player, or we know we want to do what. When we look at the box, okay, we know we need to push it. When we look at the goal pace, oh, we need to cover it. So that is the pattern recognition. For the player place, we got red, yellow, and green. When we see the red circle, which means that do not complete the sokoban. So we need to complete it. And then we cannot answer the question. Next, when we see the yellow circle, which means that we already complete the sokoban. Now, step on it and answer the question. For the green circle, which means that, oh, we already answered correct. So for this player place, actually it got 3 color, and 3 color means the different command. In the game, actually we didn't write any instruction of it. So we need to know, oh, the red color, which means we haven't complete yet. Moving on to the extraction. So extraction is focusing on what matter. Okay, what we're going to do in this game. What is the main point? So students focus only the key detail, just like using the variable and hiding everything else. So they just learn to simplify the problems and focus on what matters. Okay? Firstly, play sokoban. Okay, so we need to play to answer the question. After that, level up. Just like that. And last, we are going to algorithm design. So algorithm actually is creating a clear solution step by step. For this game, we start off with the button start, and then we need to control the player. For what? To push the box to the green square. After that, when the green circle turns yellow, when the turn yellow, step on the yellow circle, and the question will appear. So answer the question. Okay? And then we will go into 2 situations. Either we answer correct or answer wrong. If we answer correct, the yellow circle will turn to green, and then we will continue to the next level. But if we answer wrong, we will back to control the player and then start off from the upper part to the lower part. So this is the algorithm design. In the classroom, teacher can set a time so that the student with the highest level will consider as a winner, and that become a competitive experience. Not only that, this game is provide an active math practice. Students aren't just solving addition problems, they are moving, thinking, and applying math in an interactive way. Next, encourages the computational thinking. So sokoban actually is require planning ahead, breaking problems into steps, and using logical reasoning. Skills that align with computational thinking. Furthermore, gamified learning is equal to higher engagement. While we're turning math into the puzzle game, it increases the motivation of students. The challenge of solving a level, thinking about sums and fun layer that keeps students' interest and focus. Lastly, we can promote step-by-step problem solving. Just like solving a multi-step equation, sokoban teaches students to think order, sequence, and cause effect in math operation. In conclusion, this gamified approach makes learning math more interactive and fun, while also building foundational skills essential for coding, robotics, and discipline. As a result, instead of just solving problems, they understand the logic behind. Now, I'm going to show you all the offline software, which called SOH ZHE. is a derivation from tic-tac-toe. Tic-tac-toe is a paper and pencil game for 2 players who take turns marking the space in the 3x3 grid with X or O. And the player who succeeds in placing 3 of their marks in horizontal, vertical or diagonal row first is the winner. Besides that, our learning standards still remain the same, which is Year 1 Topic 2 Addition. Normally, this game can be played with only pencil and paper, but I have modified it to become more interesting. So what did I do? Let's check it out. Firstly, prepare a cardboard, then draw a 3x3 grid on it. In tic-tac-toe, we got X and O, but now we use square and circle, and this time we add a special character, which is the shape triangle. So far, the cardboard is done. So we need to prepare the questions, but how? Just straight away to ChatGPT and ask for 20 additions question with specific request, and then nail. Then open Microsoft Word and arrange it nicely. And also don't forget to prepare the answer sheet. After that, print it out. After printing, cut the questions into the small pieces and then fold it. Get a cover box to fill in the 3 shapes and a small container for the questions. Until now, actually all the instruments have already well prepared. Don't forget the answer sheet. Let's start playing. This game can be played by individual or a group, but at least we need 2 players. And now I'm going to demonstrate it. So first, we need to choose our side, whether it's a square or a circle. And then use our feeling to touch in the box to find where is our shape. For example, if I am a circle, so I need to touch, oh, the circle is curved surface. So and then I take it out. If I am a square, so I need to touch, oh, it's called diagonal, and then we pick it up. After picking our shape, then pick a question in a small container. In this stage, we can start answer our question. If we answer correct, then put our shape in the grid and start playing tic-tac-toe. So far, there will be some question and situation here. So now I'm going to explain how it works. If my shape is circle, I need to pick up the circle shape. But what if I pick up a square, I need to put it back. Okay, until I pick up a circle. So after we answer the question, who will check the answer? So actually, there will be an answer sheet. If there are 2 players, we can check by ourselves. If there are 3 players, so the third player will be checking the answer. If I answer correct, then put the shape in the grid. If I answer wrong, just put the shape aside and it disqualified. So we cannot use the shape already. And we need to pick up another circle shape for us to answer the question and then score the tic-tac-toe. So I have mentioned just now, we got the triangle shape, right? So what is the function of the triangle shape? If we pick up the triangle shape and now it's time to show the special movement. Actually, the triangle shape is used to remove one of the shape of the opponent. When we pick up, we need to use it straight away. We cannot hold it or left to the next round. If we pick up the triangle shape in the beginning, means that there is still no any opponent shape. So we can't use it and the shape will be disqualified. So the point is we need to pick up the right shape instead of picking another shape, either in the beginning or the process. So after round and round, if one of the players has scored the tic-tac-toe, either row, column or diagonal, and the player will consider as a winner. At that time, the game is over. Last but not least, always prepare and stand by the answer sheet. After watching the demonstration, let us discuss about the integration of computational thinking in this activity. Start with decomposition. So it seems like complicated, but when we decompose it, we will know what we're going to do. For example, when we play the game, first we need to choose our shape, and then answer the questions, and then take the shape, put into the grid. So understand all the instructions, and then we know what we're gonna do. When answering the question, we are getting input. So we just decompose all the instruction, all the process into small parts so we can well understand it. Moreover, we need to check the answer, whether it's right or wrong. And lastly, play the tic-tac-toe. So in this decomposition, we can split all the complicated problems into a smaller parts to let us understand and clear the instruction. Secondly, we are discussed about the pattern recognition. So in this game, we have only 3 patterns. The first is the square, and the second is circle, and the third is a triangle. For the square, it represents the player A shape. For the circle, it represents the player B shape. While for the triangle, it's a special shape. It's used to remove opponent shape on the grid. When we're talking about abstraction, we need to find out the focus of this game. So we are going with answer the question and then play the tic-tac-toe. That's all. Only have 2 dominant points, instead of thinking all the complicated process. And now we are discussing about the algorithm design. Assume that my shape is circle. Then start off. Pick a shape in the box. Now we have 3 situations here. So we're going one by one. If I have picked up circle shape, then pick question and answer the question. After answering the question, we are going to correct or wrong. If we are correct, then put the circle in the grid. To complete a full column, row, diagonal with circle considered as win. If we answer wrong, we will back to the first step. Pick another shape in the box. As a result, this is the situation when we pick up the circle shape. But what if we pick up our opponent shape? So when we pick up the square, we need to put it back into the box. And then back to the first step. Pick another shape in the box until we pick out our own shape. And then we can process to pick a question, answer the question, and moving on the next step. And now, if we pick up the triangle special shape, we need to use it as remove one square on the grid. After we remove, we need to back to the first step. Pick a shape in the box until we pick our own shape. So this is the algorithm for this game. So the truth is, we need to pick up our own shape instead of other shape. And then keep repeating the same step to score the tic-tac-toe. So the integration of this offline technology in mathematics education, we can mix addition fun and game-based, like we are turning the addition into the game, add on some assignment and engagement, reducing maths anxiety and encouraging participants, especially for students who may not enjoy traditional drills. Thus, we are able to reinforce our student mental maths. In order to earn their spot on the grid, students must solve an addition problem. This builds their quick thinking, fluency, and confidence in doing math mentally. Moreover, encourages strategic thinking. Beyond just math, tic-tac-toe requires players to plan moves, predict outcomes, and block opponents. As a result, this helps developing logic and decision-making skills alongside addition. Furthermore, promotes repetition with purpose. Unlike worksheets, students want to keep playing. So, these repetitions helps reinforce addition fast without it feeling boring or forced. Lastly, builds social and collaborative skills. When playing teams or pairs, students naturally talk about strategies, explaining their math reasoning and work together. As a result, they are boosting their communication skills and cooperative learning skills. So far, this simple yet strategic game naturally promotes key elements of computational thinking as students analyze possible moves, predict outcomes, and adapt their strategies. They are unknowingly applying algorithm thinking in a hands-on and collaborative setting. So this offline format of tic-tac-toe makes it accessible and interactive without the needs of technology, making it ideal for reinforcing math skills in a fun and meaningful ways. In a nutshell, these are the integration of technology and computational thinking in mathematics education. The online software is called SOKOSUM, while the offline software is called SOH. These two software are focusing Year 1 Topic 2, Addition. In the end, I hope you all like this video, and I also hope this software can help you all in mathematics education. Thanks for watching. Bye bye.